Welcome back to the Easy VC Brief. I'm your host, Max von Polnitz, and this is your weekly espresso shot to deep tech venture capital news. Also, check out the new gear. I hope my voice is even more crisp. So let's set up today's episode. It's all about AI and material science research and how they're converging. At Ajinomoto, R&D efficiency has always been top of mind. But let's first discuss the classic problem. You discover something remarkable in a lab, a new catalyst, a better polymer, a next generation battery material, and then nothing happens. Or more precisely, nothing happens fast enough. The graveyard of material science is littered with brilliant discoveries that never made it to manufacturing, let alone to an application. Why? Because the journey from a novel molecule on a whiteboard to a material that actually performs in a factory at scale, at cost, involves a completely different set of problems. That bottleneck is exactly what a new wave of AI-powered material science companies are trying to blow open. Today, we're looking at three of them, each with a very different strategy and different business model. Today's bod will be a bit longer than usual given the complexity of the topic, but let's dive in. Lila Sciences was built inside Flagship Pioneering, the same venture studio that gave the world Moderna, and officially came out of stealth in March 2025. Their ambition is not subtle. They call it scientific superintelligence. If that makes your eyes roll, let's first learn more. Here's the core idea. Instead of relying on models trained purely on existing data, Lila's AI generates hypotheses and then tests them directly in an automated lab. Robotic arms, magnetic conveyor lanes, the whole science fiction setup, while collecting data and updating its understanding in real time. It runs the experiment, learns from the result, and decides what to do next. That closed loop is what makes this genuinely different from most AI for science plays. The company has now raised $550 million, a $235 million Series A, and a recent extension that included NVIDIA's venture arm, pushing its valuation past $1.3 billion. Yeah, that's some serious dry powder. Think of it like this. Most AI in science today is like a really well-read grad student who has memorized every paper ever written, but has never actually touched a pipette. Lila wants to build the version that also runs its own experiments at 3 a.m. on a Tuesday automatically. For companies like Ajinomoto, which run serious R&D across amino acids, specialty chemicals, and food ingredients, a platform like Lila represents a real strategic question. Do you partner with it? Do you build your own version internally, or do you wait? That's not a rhetorical question. It's true for major incumbents, and we'll need to see how this plays out over the next few years. Our second story is about Orbital Materials, and this one has a pedigree worth noting immediately. It was founded by Jonathan Godwin, who previously led materials research efforts at DeepMind, the same lab that created AlphaFold. He saw what AI did for protein structure prediction and essentially asked, what if we did that for physical materials? Orbital's AI model predicts the properties of new materials by training on public data sets, computer simulations, and experiments run in its own in-house lab. The target applications are heavily climate-focused, better catalysts, carbon capture sorbents, materials for next-generation batteries, and green fertilizers. They recently raised also $200 million Series B at a $1.2 billion valuation led by Radical Ventures. But what makes Orbital's model interesting and distinct from Lila is their philosophy on the manufacturing handoff. Rather than manufacturing materials themselves, Orbital aims to bring new compounds to proof of concept or pilot demonstration stage, then hand them off to external manufacturers for commercialization. They're not trying to be a chemical company. They're trying to be the discovery engine that feeds chemical companies. A fun way to think about it, Orbital is playing the role of an elite film development studio. They find the story, develop the script, bring it to a finished rough cut, and then license it to the studios. Capitally efficient, if you can pull it off. The risk, of course, is that exact translation gap we opened with in the intro today. Getting a material to pilot is not the same as getting it to a production line at commercial scale. That last mile is where a lot of promising materials have gone to die. But technically, Orbital is notable for releasing Orb, one of the leading open source neural network potentials for atomistic simulation, capable of modeling systems of up to 100,000 atoms with energy and force evaluations running in under a second. Clearly, these are all R&D questions and partnership questions that even companies like Ajinomoto must monitor. Now, let's come down a few altitude levels, because not every AI materials company is trying to build $1 billion autonomous robot lab empire. Some are just trying to make computational chemistry, which is frankly one of the most inaccessible scientific disciplines on the planet, actually usable by the scientists who need it every single day. That's Rowan Scientific. Raised a $2 million seed round in 2024 and founded by two brothers, Corin and Ari. The company's explicit goal is to make computation chemistry as easy as it is to use Uber, which is a heroic task. I love the startup vision. I love their focus. And their product is a web-based SaaS platform. And what's notable is just how complete the tool set is. We're talking molecular geometry optimization, conformer searches, relative binding free energy simulations, even NMR spectral prediction coming later this year. It's not a niche point solution. It's designed to cover the full computational workflow a medicinal chemist or material scientist touches on a daily basis. Supposedly, they have over 10,000 scientists already working on the platform. Pricing is also unusually transparent for deep tech. Usage-based credit pricing for smaller teams, annual packages starting at $50,000, and enterprise deployments with dedicated support. That's a SaaS model that feels more like a modern dev tools company than a legacy scientific software vendor. The technical differentiator worth noting as well is Rowan combines classical physics-based quantum chemistry methods like DFT with neural network potentials trained on millions of quantum mechanics calculations, giving scientists both the accuracy of first principles modeling and speeds that are orders of magnitude faster. That is not minor optimization, and I'm excited to see where this startup goes. So, what does this landscape tell us? 3 companies, 3 very different bets on where value gets captured. Lila is building the infrastructure play, own the factory, own the data flywheel, be the platform. Rowan is building the tool layer, trust the partner, SaaS, low friction, high daily active user adoption among practicing scientists. And Orbital is the discovery specialist. Find the material, prove it, and hand it off. For anyone thinking about AI and how it fits into an industrial R&D strategy, whether you're running a corporate venture fund or sitting on a committee at a major chemical or food ingredient company, the question isn't whether AI is going to change material science. It already is. The question is where in the value chain the durable, defensible value actually gets captured. That's your brief for this week. I'm Max von Polnitz. As always, see you next Thursday. And please keep building. Thanks.